students, good morning. This is a small step for you to realize the subject, and I am recording this portion so that you can review and also use the recorded videos, and repeatedly seeing the recorded videos may helpful to develop your subject. And this is the first unit. I am trying to cover as much as possible in first unit. So we'll start with estimation. Actually, you all know that we are going to study how to estimate an estimator using the method of moments as well as MLE, that is maximum likelihood estimator. Before getting into the subject, we first know about what is meant by estimation. Estimation, estimate and estimator. So the estimator is a statistic whose calculated value is used to estimate a population parameter. And the estimate is a particular realization of an estimator. You obtain an estimator. The estimator is a statistic whose calculated value is used to estimate the population parameter. Suppose think that in previous semester class, you would have come across the statistic, that is T statistic, F statistic, chi-square statistics. All those statistics whose calculated value is used to estimate the population parameter theta. So you try to estimate the value x bar minus mu divided by the standard error of mu you would have used. So such statistic is used to estimate the parameter theta. So in T statistics, you use T statistics to estimate the sample mean. Whether you are going to check that whether the sample mean is equivalent to the population mean. The same way, here estimator is a statistic whose calculated value is used to estimate a population parameter theta. Okay. So for T, the parameter is sample mean, and for F, the population parameter is standard deviation, sample standard deviation. Then estimate. Estimate is the particular realization of that estimator, that is theta hat, the value of theta hat. So finally you arrive at a numerical value in a T statistic or in F statistics at chi-square also. So that is called an estimate. So these things, estimator and finding the estimator and finding an estimate, all these things are called as estimation. The process through which you obtain the estimator, estimate, all these things are called as estimation and theory of estimation. So there are different types of estimator. Point estimator, interval estimator. So the point estimator is a single value, whereas interval estimator lies between the interval. So there is some range, least to the upper, lower limit to the upper limit. So we call it as confidence interval, right? So in interval estimate, you will have confidence interval, and in point estimate, you will have a precise value for the estimator theta hat. So there are different types of to estimate an estimator, and we also know the properties of good estimator. This you would have come across in your previous semester class, that what are the properties of a good estimator. The estimator need to be unbiased, the estimator need to be consistent, sufficient, and so on. Like that, some of the qualities describe a good estimator, right? The frequencist world, that is frequencist, we know individual value helps a statistician. Only a group of values helps a statistician. That is what it is called as frequentist. World view parameter are fixed. Statistics are random variable and vary from sample to sample. Okay. So parameter are the population constant, statistic are the sample values obtained from the random sample values. So now what is the popular view that parameters are fixed, statistics are random variables. So statistics may vary from sample to sample. In theory, there are many potential estimators for population parameter. Okay, so you will have so many estimators for a population parameter. That estimator are identified because of their characters. So the characters decides whether the estimator is good or not. Okay, so now check what are the characteristics of a good estimator. The estimator need to be consistent, unbiased as well as precise. So for a consistent estimator, the difference between the estimator minus the estimate, that is population parameter theta. So the modulus, the absolute value of theta hat minus theta is greater than epsilon when it is raised to the limit n tends to infinity equivalent to 0. Okay, as sample size increases, theta hat gets closer to theta. Okay, so the realization of the statistic estimate, that is the value obtained through the statistic is the here the value obtained through the statistics whose calculated value is used to estimate population parameter, that is you obtained theta hat. Okay, that particular theta hat and the parameter, population parameter theta, when you find the difference, the absolute difference will equivalence to 0 when n tends to infinity. So the theta hat get closer to theta means theta hat and theta are one on the same when n increases, when n tends to infinity, when n becomes large. Okay, and the unbiasedness, when theta hat, expectation of theta hat is equal to theta, that is expectation of the estimator, the expectation of the estimator equivalent to population parameter. Okay, on that case we say the estimator is unbiased. And precise, precise means the sampling distribution of theta hat should have a small standard error. Okay, when the standard error is decreased, what is standard error? The standard deviation of the population parameter. So standard deviation of the population parameter is small. What does it mean? When it decreases, that is variation between the random samples and the mean reduces, right? So what is standard deviation actually? It is square root of sum over x minus x bar the whole square divided by n or n minus 1 as depends upon whether you are calculating for population or for the sample, right? So like that, when the standard error is small, that variability becomes small. So then you call the sampling distribution theta hat may have a precise, have a characteristic precise estimator, right? So now this is the visualization how biased, precise, imprecise, unbiased, precise, unbiased, imprecise all together, right? We'll pass on to the next. Yes, the methods of point estimation. Popularly known three methods are methods of moments, maximum likelihood, and Bayesian. Bayesian is not there in your syllabus, so we concentrate upon method of moments as well as maximum likelihood estimator, the estimation process. Okay, method of moments as well as maximum likelihood estimate, both estimation are point estimations. Okay, you will get a precise plausible value of theta hat is equal to theta. Next, the advantages and disadvantages of method of moments and advantages and disadvantages of MLE and some of the problem we already have discussed that we are going to see now. I'll switch on to the next slide. Right, this is our class introduction. Right, so from here we start. Previously we have discussed about your previous semester portions. Now we are getting into our own syllabus. So in this you have how to find the estimators and what are the methods to obtain an estimator, and the point estimators, and also interval estimators, that estimating confidence intervals. Okay, so in this we need to find estimators. So estimators by Fisher's criteria for the best estimator do not provide themselves any method for getting these estimator. There are few commonly used method available for obtaining good estimator. So whenever you try to find an estimator, that won't happen naturally. You need to engage some method to get a good estimator. So we have two methods for our syllabus, that one is method of moments and maximum likelihood estimation. So method of moments. What is method of moments? Method of moments is, you already have studied about the moments and how to generate moment generating function, and also some of the moments, the first raw moments and central moments. From the raw moments we obtain the central moments. The central moments obtained are the description of the distribution. So first central moment, that is mu1, is equal to the mean. The second central moment mu2 is equal to the standard deviation variance, and the third, fourth central moments are used to obtain skewness and kurtosis. So all these are the properties of a distribution, right? So the moments describe the distribution. So the moments are used to estimate an estimator. So now we go by the definition. Let x1, x2, etc. xn be random sample from a population with PMF or PDF. So PDF x describes, that random sample describes theta 1, theta 2, etc. up to theta k parameter. The method of moments are found by equating first k population moments to corresponding sample moments and solving the resulting system of equations. Right? So this is my population moment, that is mu k is equal to expectation of x power k, and sample moment is mk is equal to 1 by n sum over xi to the power k. Right? So now I need to equate this population moment mu k is equal to mk to obtain an estimator through the method of moments. Now check the method of moment estimation, how it happens. Now I need to equate mu1 to m1, mu2 to m2, mu3 to m3, and so on. So what is m1? It is 1 by n sum over I ranges from 1 to n xi, and m2 is 1 by n sum over I ranges from 1 to n xi square, and mu3 expectation of x3 is equal to 1 by n sum over I ranges from 1 to n xi power 3. Continue this until there are enough equations to solve for the unknown parameters. Okay, so we continue this and solve to obtain the unknown parameter, estimator to obtain the unknown parameters. So there are some drawbacks in method of moments and some advantages in method of moments, and even in MLE there are some drawbacks, and in Bayesian is so popularly used, and it is the PG level portion. So when you go to the post graduation,